Hello friends, in this video we are going to see design of doubly reinforced beam in working stress method. Design a doubly reinforced concrete beam for a residential floor of the building to suit the following data. Effective span 5 meter, dead load 8 kN per meter, live load 12 kN per meter, width of beam 250 mm, overall depth 500 mm, use M20 and Fe415 bars. So the given is effective span 5 meter, dead load 8 kN per meter, live load 12 kN per meter, width of beam 250, overall depth 500, FCK 20, FY 415. Next step, design constant. Q formula is 0.5 into sigma CBC into N into J. Sigma CBC value is in IS456 page number 81. So N formula is M into sigma CBC by M into sigma CBC plus sigma ST. Sigma ST value is in IS456 page number 82. M formula is 280 by 3 into sigma CBC. J formula is 1 minus N by 3. So calculating in this formula we get M 13, N 0.283, J 0.905, Q 0.890. Next step, dimensions. Here in question they have provided overall depth 500, so we must calculate depth provided. Depth provided formula is overall depth minus clear cover. Clear cover for beam is 50, so depth provided answer is 450 mm. Next step is load calculation. Self weight equal to breadth into overall depth into 25. Dead load, live load is in question. So load answer is 23.125 kN per meter. Next step is calculating bending moment and shear force. Bending moment formula is WL square by 8. W value is 23.125. L is effective span given in the question 5 meter. So the answer of bending moment is 72.26 kN per meter. Shear force formula is WL by 2. So the answer is 57.81 kN per meter. For doubly reinforced beam, we must calculate M1 and M2 to find tension and compression reinforcement. So here M1 formula is Q into B into depth provided. M1 answer is 45.05 kN meter. M2 formula is M minus M1. M is 72.26, M1 is 45.05. So the answer of M2 is 27.26. Next step is tension reinforcement. So here we must find number of bars. Number of bars formula is AST1 plus AST2 by small AST. So AST1 formula is M1 equal to sigma ST into AST1 into J into D. So AST answer is 480.422 mm square. Next AST2 formula is M2 equal to sigma ST into AST2 into depth provided minus clear cover. So AST2 answer is 296.304 mm square. Small AST formula is pi d square by 4, diameter is 18 mm, assume answer is 254.46. So number of bars is 3.05. Rounding it, we take it as 3 bars. Next step is compression reinforcement. Here we must find number of bars. Formula is ASC by small ASC. formula for ASC is M into AST2 into D minus NC equal to ASC into 1.5 into M minus 1 into NC minus DC. So here NC value is calculated in this formula, N into depth provided, BC is clear cover. So AC answer is 866.93 mm square. Small AAC formula is pi d square by 4. D is 18 mm. So the answer is 254.46. Number of bars equal to 3.4. Rounding it, we get 3 bars. Next step is check for shear force. This is to find tau V and tau C. Tau V formula is in IS456 page number 83. So the formula is shear force by breadth into depth provided. So tau V answer is 0.514 Newton per mm square. Now we must calculate tau C. For tau C we must find percentage. Percentage formula is 100 into ASC by breadth into depth. ASC is area of steel in compression reinforcement. So percentage answer is 0.77. So we must refer IS456 2000 page number 84 table 23 to find tau C value. This is IS456 2000 page 84 table 23, value is 0.77. So nearest value must take 0.75. In question they have given M20 concrete, so you have to take 0.35 value. So tau C value is 0.35. You have taken 0.35 tau C value. Since tau V is greater than tau C, here tau V value is 0.514, tau C value is 0.35. In IS456 page number 85, they have given when tau V exceeds tau C, given in table 23, shear reinforcement shall be provided in any of the following forms: A. Vertical stirrups, B. Bent up bars along with stirrups, C. Inclined stirrups. So for shear reinforcement we must find spacing when tau V exceeds tau C. We must calculate in vertical stirrups formula. Vs equal to sigma SV into ASV into D into spacing. Vs formula is V minus tau C into breadth into depth. So in this formula we can find spacing value if tau V exceeds tau C. This is in IS456 2000 page number 85. So we get spacing answer 282.23. Rounding it we get 300 mm. Provide 8 mm dia bars of spacing 300 mm. If tau V exceeds tau C, we must find spacing. Next step is reinforcement details. Reinforcement details is the data overall found in this problem. Overall depth is 500 mm, effective depth is 450 mm, effective span 5000 mm, support width 250 mm, tension reinforcement we have provided 3 numbers of bars of 18 mm dia, and compression reinforcement we have provided 3 numbers of bars of 18 mm dia. Provide 8 mm bars at spacing 300 mm center to center. So here this is overall depth 500 mm, depth provided 450 mm, breadth is 250 mm, top bar is compression reinforcement 3 numbers of 18 mm dia bars we have provided, bottom is tension reinforcement. This is doubly reinforced diagram. Thank you.